Hello everyone, welcome to AI Anytime channel. In this video, we are going to implement RAG, Retrieval Augmented Generation, using a framework called Haystack. Okay, and we're also going to use a newly released large language model called Mistral. I don't know how do we pronunciate it. It's a word I think been used in France because the model has been released from France. So it's Mistral, whatever. Okay, so which has claimed that Mistral has uh, surpassed Llama 213B, of most of the benchmarks that they have tested, which is really surprising to see a 7B model overtaking a 13B model, which we have earlier seen with other models as well, like 5 1.5, which on few benchmarks has also surpassed a lot of other models. So we're going to use Mistral 7B with Haystack. We are not going to use LangChain in this video as of orchestration framework for building LLM application. We are going to use Haystack framework, okay, by DeepSeek, because which is more suitable for production. I think they have a better orchestration mechanism for implementing these algorithms that we work with in the backend, the document parsing, pre-processing, the retriever, the pipelines, etc. So we're also going to use a vector database here. We are going to use a vector database. We are not going to use a vector store in this. We are going to use Weaviate. So we'll use Weaviate, we will set it up in our local machine, and everything will be locally on a CPU machine. We'll download a 7B quantized model of Mistral from the block, and we'll use Haystack, Weaviate, combine it together to build this application that you currently see on my screen. It says Haystack RAG implementation. Now it has an input box where you enter your query and it will try to generate the response which is an answer for you, okay, with some set of documents or context. So let's see that. Now this video has been requested by a few of my subscribers to create how we can build a RAG kind of an how we can do a RAG kind of an implementation using Haystack on a PDF documents, that too with open source model. Maybe I can also show you that how you can do with GPT 3.5, and it's just a single line of chain that you have to make. So let's see, we're very excited. This video is going to be long, so if you are not somebody who likes to write code and follow along, skip all of the things that I'm talking and you can just take the code from GitHub repository. Choice is yours. Now let's jump in and see. Now if you see here, it says enter your query. I'm going to just click on submit. Now once I do submit, it takes around 30 to 45 seconds on my machine because it is running on a CPU. It does not utilize any of the CUDA GPUs that I have. So I will click on submit, will stop the video and come back once I see the answer, and then we'll start implementing this application. So let's see that. Now once I click on submit, what it does, it goes back to the retriever in Weaviate that we have created. So it goes to the vector database, looks at the vector chunks and try to find out the relevant chunks in those vectors, and then combines the prompt with those and feed it to an LLM to retrieve response. That's what it's currently doing in the backend. So let's see what kind of response we generate from this. So let me pause the video here. I must come back once it's done. Okay, so you can see that we got our answer, and the question was, why was the manual of air traffic services prepared? And it says the manual of air traffic services, which is being called as MATS, part 1 was prepared for the use and guidance of executives and staff of Airports Authority of India. So you can see here we have created a knowledge base, and the document that we have taken is of something called Airports Authority of India, AAI, which looks at everything that happens within India for our airports authorities. Now the answer has been retrieved, and you can see, beautiful answer. The purpose of this document is to establish procedures, provide information to the pilots, and instructions, whatever. Now the reason why I'm building this application is we have earlier built something called Law GPT. We have built something called medical chatbots. We have built, Stack Overflow GPT, Code GPT, BJP GPT, Politics GPT, n number of other GPTs that we have built. By the way, those are not GPTs, but we have tried replicating the same building a question answer tool, a RAG implementation, or your knowledge base. Now, how we can build an application just to showcase the capabilities of an application that will really help, the ATC and the pilot conversation that we have seen, right? How the air traffic controllers, they have a conversation with pilots when you board a plane, right? They give the instruction that, okay, you have to fly on that altitude, the traffic is like congested, blah, 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 right? So now, these are all manuals that these organizations, like in India, we have Airport Authority of India, AAI, they create these manuals for the ATC folks, and these guys have to go to this manual in their training period. They have to learn through all of these steps. They have to see that how they can follow the protocols when they are communicating with the pilots. Can we use generative AI to simplify this process? Can we use generative AI to help air traffic controllers, in some way? The idea that excites me, right? And it can help you in the compliance, it can help you in the auditing processes, because these calls are also being recorded, and this can also help you, right, to learn faster in your training period as well. So this use case is mainly towards transportation, right? The airport, we have seen the uh, air traffic controller. So maybe this can help them. Not this application, of course, but this can be, if any one of you are looking forward to build something, you can take some inspiration from this. Now, this is the answer that you see, the manual of air traffic controller. This is the answer. Now, this is the relevant documents. I'm not returning the source document. Maybe you can have a PDF viewer to do that, but I'm just getting the context out of it. Okay, this is how that looks like. You can see the document one. Here you can find out all the basically the context behind that answer has been passed to the model, and how the model has retrieved from this. You can see it says intentionally left blank and all. And we are using Mistral here, guys. So we are using Mistral LLM just to combine Mistral with Haystack, with Weaviate. I'm not going to cover Mistral in this because there are thousands of videos already available. I guess so far all the YouTubers would have created videos on Mistral. They are focusing on group query attention. They have a different attention. Like they have focused on different way of basically optimizing those layers that we talk about, like grouped query attention, sliding window attention. They're looking at BPE tokenizer, right? Byte fallback BPE. If you don't know what BPE tokenizer is, go through OpenAI cookbook on GitHub repository. They also use BPE tokenizer. So this model have focused on all of these things to make it better than all other 7B or 13B model that they say, like Llama 213B, for example. And you can read about that in this blog post. They have a blog post over here. Mistral 7B, the best 7B model to date, Apache 2.0. So you can use it for commercial purposes, guys. Fantastic, right, by Mistral AI. Now, you can see Llama 2, 13B, 34B on many benchmark. Code Llama also uses grouped query attention for faster inference. Makes sense, by the way. That's why I say optimized, right? I use the word optimized. They're focused with how to look at this attention when they're talking about the attention layers, how they can optimize it. And that's where the real realm is, guys, to be honest. Now you just sliding window attention to handle longer sequences, smaller code. Fantastic, right? This is what some charts and blog, you can read it. I have gone through it. I like the model, to be honest, and that's why I have picked Mistral to combine that with Haystack as an orchestration framework, and how we can use a vector database Weaviate completely. Let's build that now, guys. So what I'm going to show you is maybe the document. So the document that we have. So currently you can see, let me go to data. You can see I have this file called ATC manual. I will split it. I will show you when we're creating the embeddings. And now we're going to write the code in VS Code and start building this application. Okay, so let's open the directory here. So haystack rag. This is my directory, and there are a few things that I'm going to explain here. So let me just open in terminal. I'll go a little faster on this utility things which are not required. I assume that you are a programmer and you can understand these things. Now what I'm going to do here is cd script, and just you can do it in one line as well, blah blah blah. Clean code inside. Okay, so this will open VS Code, and then I will explain what are these files. Okay, you do not have to worry about it. If you don't understand, it's okay for now. Now I have two folders. One is static, other is templates. Now you could see the front end, okay, the application Haystack rag implementation, the dark theme where I put a question and I got an answer. So what I'm doing here is I'm creating my backend in FastAPI. So we are going to use FastAPI library to create completely, API driven application here in this video. So we'll do some, we'll have some API endpoints that we're going to utilize in our front end. Now backend will be in FastAPI. On the front end will be in Bootstrap, HTML, CSS. Okay, and I'm not going to cover those. So this will be available on my GitHub repository. You can find this front end thingy on the GitHub repository. I'm not going to cover that. I'll focus on how you can set up Weaviate, load data, which is your PDF, create embeddings, store that in that vector database which is running on inside a Docker container, and then how you can use an LLM, open source LLM with Haystack, and that to Mistral 7B to go and take the chunks and understand the context to retrieve the information for you. That's what I'm going to do here. So for that, you can see the model. We have two models. One is Llama 2 7B32K, the other is Mistral 7B Instruct. You will get the link in the description that where from you can download this model. I'm using a quantized 4 KS model. Okay, you can see it over here. Mistral 7B, it is from the block, and then I have my data over here in something called ATC manual split.pdf. Okay, and now I have templates, static folder, and then I have an env file, because I'm also going to show you that how you can use GPT 3.5 inside Haystack. And then we have a file called model.add.py. Okay, now this file is it helps you to define a class called llama cpp invocation layer. Now through this prompt model, the Haystack gives you an option to also utilize this LLMs through their prompt node. I'm going to talk about it when I'm writing the app.py file. Now let's start with something called docker compose YAML. Okay, so I have a file here that's called docker compose file. Now why I'm doing this, guys, because let's go on Weaviate. Now if you come to Weaviate, it says the AI native vector database. It's an open source vector database. It allows you to store data objects and vector embeddings from your favorite ML models and scale seamlessly into billions of data objects. Focus on the word billions here. Now, if you have one small PDF, of a small amount of data, it's okay to use vector stores like Chroma and Fast, because these are in-memory vector stores. Now, what if you want to, scale your application where you have millions and billions of objects, the floating points, how you can store them? For that you need a vector database, and that's where vector database like Weaviate, I'm talking about open source first. You have Weaviate, you have Milvus, you have Qdrant, you have a few others as well, to use as a open source vector database. So here we are going to talk about Weaviate because they really do good job when it comes to efficiency. So I'm going to focus on Weaviate, but you can also look at Qdrant and Milvus if you want to have a look at those. Now you also have a closed source alternatives if you want to pay money, right? We have Pinecone, which provides a free subscription as well on their starter package. You can also have a look at that as well. Pinecone is very famous, but I'm gonna use an open source alternative, Weaviate, in this video, because I assume that if you are working for some big clients, they will not be they will not fancy using a third-party vector database, because they will be concerned about data protection and privacy, even though these guys claim that they will not look at your data, which I believe them, by the way. But so Weaviate, now if you come here on documentation, if you come how to install, they have different ways of installing. The first thing, it also provides you a similar cloud service like Pinecone. Now if you want to use Weaviate cloud service, it's easier for you. You just go and create an account and set it up like Pinecone that you do similarly. Now again, but you are sending your data to them, but you can also set it up locally, and that's what we are doing. The best way of setting up locally is through Docker Compose. You can see it over here. It says Weaviate supports deployment with Docker Compose, which allows you to run Weaviate on any operating system supported by Docker. That's the beauty of Docker, by the way. You are on Linux, you are on Windows, you are on Macintosh, you are anywhere you are, right? You can use that, by the way. Now, so you can see it says to start Weaviate with Docker, you can use a Docker Compose file called dockercompose.yaml, and that's the file I have downloaded. You can see it says use the starter Docker Compose file. So let me walk you through that. Once you click on this, it will say, you can download the file from here, and then you have to do Docker Compose up that I'm already running. I will show you. Now let me first show what I'm going to do here. If you see this Docker Compose, what they are doing here, guys, they are first defining a version. This is the latest version they would have been, using. Then they have some services. It had layers that they have defined. Now, services and volumes. Now, if you look at the services, they are saying, okay, use the Weaviate service, and these are the port that it runs on. It runs on 8080 port, by the way. I'll open that, and then they say, okay, download first the image. So you need a Docker image first. So the Docker image of Weaviate will be downloaded from this semi-technologies/Weaviate. If you go to Docker Hub, you can find those details. Okay. Now it runs on port, so the port mapping has been done, and it creates the volume. You can also define a path somewhere else if you want to see the created volume of that. You can also do that, by the way. Now in environment, it has a few details. It says, okay, persistence data path. So it has a data path that is similar to Weaviate data path that you see in volumes, because that's where all of your volumes will be created. And then it has clusters and modules. Modules are important. So these are the modules that are supported by Weaviate and enable. Like for example, if you see, you can use Coher models, you can use Hugging Face, you can use Palm from Google, then you can use OpenAI. I'm gonna use that. You're gonna use generative OpenAI, Coher, Palm, etc., because it provides different kind of retriever and generation modules. Now this is your compose file. Now how are we gonna use this, guys? Let me first show you. I have something called, let me just close this. Now I have something called, you can see it over here. I have a Docker desktop, which if you go to containers, let me just show you, it has something called Haystack rag, which says running. So my container is already running, as you can see. This is my name of my container that I have, and this is running inside. You can see 3 hours ago. Now if you come to images, it will show you that I have one image that we have downloaded from Semi Technologies from Docker Hub. Right, that's what you can see the size over here. Now this is Docker desktop. You can also set it up. Now let me just go here and run. If you come here and run localhost 8080, you can see my meta information about this cluster. So it's running a cluster inside a Docker container. So you have set it up Weaviate. Now, how are you going to do it, guys? Let me first show you. As I already have done, I'm not going to basically run the command. But wherever you have the file, you can see the file is inside my current working directory. You have to come over here and you just have to do something called Docker. If you are on Windows, if you are on Linux, you have to do sudo docker compose if you haven't defined the user group in your Linux distro. Now here what you have to do, docker compose up, and I'm saying here is my file. You can see and inside daemon. So I'm going to run inside a daemon here, because in backend process, as a backend process, that's what it's going to do. So docker compose up -d, and that's the file is here. But if you have this file somewhere else, you have to go in that directory and run the command. Now once you hit enter, it will start running your it will first set it up, download this image and set your cluster up, and then it will run your vector database inside a container. And let me show you how you can see that. Now what I'm going to do, I'm going to first show you some Docker command as well. Maybe if you are not familiar, you can do Docker images to see what all images that you have in your machine. Okay, so you can see the Weaviate, and now you can also do Docker something called PS, to see what are the containers running. You can see these are the containers that I'm currently running. Let me just make it bigger for you. You can see my names are Haystack rag Weaviate 1. It runs on port 8080, and Semi Technology. Now this is how you can see. To make sure, once you do docker compose up -d, make sure to check it up if it start running. Now once you have set this up, let's start writing the app, guys. So what I'm going to do is I'm going to create a file called ingest.py. So that's where we're going to write our embeddings logic. Now the first thing that I'm going to do is haystack.nodes. And why I'm doing it, first show requirements.txt. I forgot to show you that. These are the requirements that you need. You need farm haystack Weaviate, and you need farm haystack both. You have to install haystack like this. So if you are on Windows or Linux or any operating system, make sure you have these two set it up for haystack. Now once you do that, we need something called llama cpp by Andres Karpathy. Has created those baby llamas. If you remember, baby is a llama that we have seen. Now we have llama cpp because that will help us run the gguf format, okay, to basically inference the Mistral 7b from the block. Now we have some dependencies like a cache property to run llama cpp. Then we need FastAPI. We don't need Streamlit, by the way. Just let me just remove it. We need FastAPI and Uvicon. Uvicon is a web server that runs your FastAPI application. And then we have PyPDF that we will use to basically, load the data and, do some pre-processing. And these are the deep learning libraries that we need. Let's come back over here, and I'm importing few things. And the first thing that I'm going to import, I'm going to say, okay, from haystack.nodes, import something called embedding retriever. You can see embedding retriever. One thing which might be missing here in requirements is Haystack AI. Let me just write it for you. The reason is, I will explain why Haystack AI is required, which is their upcoming version, which might not have been released officially, but they have a preview mode that I'm gonna use. I will tell you that why I'm using preview mode here, guys, for few of my tasks in this video. Now, embedding retriever, and then what we can also need is, let's also take preprocessor. I don't know why it's not small. Preprocessor, that's the, preprocessor. And we also need, let's have answer parser if you have to parse the answer. Then we don't need prompt model prompt. Let's have prompt template probably. Or why we need a template for embeddings? We don't need it. Now this is coming from Haystacks. Now what I'm going to do is, I'm going to say, okay, from Haystack dot document store, and document stores are nothing but a vector stores that we see in LangChain. I will also try to basically help you understand that how similar they are. At least from the naming convention, the terminologies have been changed, and of course it has a different way of their. LangChain has chains, Haystack has pipelines and nodes. I will explain that. Now from haystack.document store, here you have to import. Now you can see it shows me Elasticsearch. That's what also Haystack provide as an open source. I forgot to mention that. Now you have Elasticsearch, you have Weaviate, you have Milverse, you have Qdrant. 4 vector databases. Then we have Fies and Chroma as vector stores, and then we have Pinecone as a vector database which is paid. Okay, of course it's free also, by the way. Don't you come and comment and say it's free, but that might not be sufficient if you're working on a very big project. Now here what I'm going to do is, I'm going to say Weaviate document store. That's what I'm going to do here. Now we are okay with the embedding retriever for sentence transformer, and now we also have imported document store, vector store. Now I'm going to use preview and not the current Haystack library for my PDF preprocessing, because I reach out to them on GitHub repository. I put a issue also there that, guys, you have to change your dependencies. Trust me, they still relying on XPDF. Okay, when you want to run this, and I have faced struggle when you are using Haystack PDF libraries to work with on Windows machine. It really gives you error like anything. Okay, so now what they are doing in their upcoming 2.0 version of Haystack, they also have a new library that they have added called PyPDF, which LangChain also uses it, and it's easier to work with. Okay, so not required, XPDF is not required, PDF Plumber or PyMove PDF is not required. Let's work with PyPDF that works on most of the machines without much dependencies, and that's why I'm gonna use preview component. So from Haystack dot preview dot components, and from this I have a file converter, so I'm gonna use file converters dot pypdf, and I'm gonna import pypdf convert pypdf not pypdf converter, pypdf to something, yes, pypdf to document. So that's what I'm going to basically use from this haystack.preview.components.fileconverter.pypdf. This is fantastic. Now if you have to look at V and V libraries and all to guys check it out, you can also check it out here. They have a GitHub repository this for separately. You can have a look at those as well. But here you can find a hell lot of other things. You can see all the Haystack thingy and all. Okay, if you go inside Haystack and all, you will find everything. You can see the preview, and that's what I'm using, guys. If you come here on the preview folder, you will look at all of the things that I required. From preview, what I'm doing is I'm going inside component. That's how you have to basically track your libraries, okay, in a virtual environment. Now if you go inside components, I have something called file converters. Let's go inside this. Inside file converters, we have something called PyPDF. Let me open that. This is the file we are basically relying on for our PDF pre-processing, guys. I love PyPDF, by the way. Easier to work with in comparison with XPDF and PyMove PDF, which are not required. and I'm glad that Weaviate is making those changes. Now on V and V, these are done. Now what I'm going to do next is I'm going to say, okay, from Haystack import pipeline, because everything will go inside a pipeline. Fantastic. We are done with our, I'm using GitHub Copilot, by the way. Let me just ignore it. Now we are done with our imports. Now what we're going to do, let's print some statement. If we get any error, import successfully. And this video will be a little longer, guys, so as I said earlier, if you can skip all of my talking things and just look at code, but maybe I can help you learn a few things when I'm talking. So let's define our document path. So our path doc is nothing but make sure it accepts a list here. So if you are not giving this list here, you have to give when you're passing it. So right now I'm just passing it here only. So I'm just giving a list, and I have a data folder. So inside the data folder, I'm going to use the file called ATC manual. The file name, it's ATC manual. So let's just write it ATC and then manual and then split. So let's just write split.pdf. This is what I am doing. Okay, split dot. Okay, I can just delete all this, make sure that it has shown me the right thing. Data. Fantastic. Now we are okay with our document path. Now what I'm going to do is I'm going to initialize document store, and you can see I'm using Copilot. It just shows me even before I am saying. Okay, so initialize document store. I will have a variable called document under. Let's call this document store, and in this document store I'm gonna use that import that I have done, Weaviate document store. So let's do it. So Weaviate document store, and I'm going to say, okay, my host it's running on HTTP, that you can see HTTP. It's running on localhost 8080. Fantastic. I love by GitHub Copilot here. Now this is what, let's do one thing, guys. Let me first remove this. So we have Weaviate. I don't know why it's showing like it should not show like that. Fantastic. Okay, now let's call it host. This looks good. So I'm just going to replace URL, which is not an input args for this class of Weaviate document store. It's host, and in host we have to give our port here. Let's define a port here. So let me just do a port and port. So what you can do, we can bind it like this. So let me just remove this 8080 here, which is host. That's how it expect, by the way, sorry. Now import 8080, and then similarity is by default is cosine. So let's remove this, and return embedding is, let's also remove this. Let's pass the embedding size here. So I'm just going to pass embedding and embedding a dimension. So we're going to keep it default as 768, and I don't know why I have 2 here. Now what we're doing here, we are initializing a document store for that vector. So you can see document store, Weaviate document store, host as HTTP, localhost, and then I have port 8080, and then I have embedding dimension. So now let's print the document store. So I'm just going to print document store initialized. Okay, something like that. Okay, now this print has been done. So what we're going to do next is we're going to have a converter, because we have to get the PDF, get the text out of it and all, right? So you can see over here in converter, I'm going to use PyPDF to document, and it's by default it's true. So let's remove this by now, remove numeric tables, which is not required. So this is my converter initialization. Now here I'm going to pass my, let's have an output here. So I'm just going to call output, and in this output I'm going to use converter dot run, and in converter dot run I'm going to pass my path. So my path is path doc. You can see it over here. Fantastic. Now this will run that, and we can also do one thing. Let's get the docs here. So docs output document. This is fantastic. This is right. We only need the documents of that docs. Now this is right, and let's also print the docs. So let me just print docs, and yeah, this is right. I don't know why it's not required. Docs. Okay, print docs. Now here let's create a final doc. So empty list here. So final doc, which is an empty list, and in final doc I'm saying for doc, in that docs that we have in top, here we're going to create 2 things. We have the content and we have the metadata. See, when you are working on RAG implementation, it's easy to use RAG, to implement RAG. How you can do better RAG implementation? So you have to look at better way of loading PDFs, create the chunking in a better way, split the document, create the chunking in a better way. These are the few things that you need. I don't know if you heard about, GQ schema, when you are working with a JSON file in LangChain. So you have to look at these angles more rather than using an LLM, okay, just to see that how you can use an LLM. It's not required if you are building production grade applications. You have to keep your client happy and the result that they are looking for. Now for doc in docs, what I'm going to do is I'm going to first print the, let's print the doc.text, and here doc.text has been printed, and we're going to have a new doc. So new doc is nothing, let's create a dictionary, and inside this dictionary you can look at that. It's fantastic, isn't it? But I'm going to create something else here. I have my own naming convention, so let's call it content, and in content I'm going to call this as doc.txt text. Sorry, I don't know why I call it doc.txt. Now in the meta, which is your metadata, I'm going to call this as doc.metadata. Okay, this is right. Now this is done. Here we have new doc. I'm just going to append my final. So you can see this is an empty list and line number 24. I'm just going to append that in line 32. Final doc.append with new doc, and here I'm just going to say okay, print, and inside this print I'll just write something like, okay, better track it some errors and all, because it might show some error. I don't know. Now you have loaded the PDF. Now what I'm going to do is, now we have this final doc that has our content and the metadata, the text and metadata. Now we have to write some preprocessor. So let's see if we can use some preprocessor if required. So let's write preprocessor, a variable, and in this preprocessor what I'm going to do is I'm going to first use something called clean empty lines. You can see, fantastic, isn't it? Now what I'm doing here is, guys, I have a preprocessor where I'm passing some arguments. The first is clean empty lines args true, clean white spaces, clean all the white spaces, which is true, clean header and footer on the PDFs, it will also do true. Now now the text on word level, you can also do on the sentences level in Haystack. Choice is yours. See what kind of use cases you are working on. I prefer more on split it by word. If you really don't want to retrieve or generate the same words in your output, for that I will focus more on sentences. And also if your context is too big, I will again recommend you sentences in that case. But I will rather look at splitting it on the word by word. So split word, and my split length is 100, so 100 words, okay, and after every 100 words it will get splitted in different set of documents. Now this is what I am currently doing. You can increase all these numbers and all. Now let's print this here. So, or 100 might be too less, 100 word for this kind of manual. So let's basically call it 500 probably, split by word, 500 and everything. Now clean white space, I don't know, by default it's true, white spacing, let's keep it false for now. So I don't know how the PDF has been structured. Maybe there'll be 2 white space, and if it's true it will just skip all of those, and you might lose some information. Now we have a preprocessor, guys, here. Now what I'm going to do next is I'm going to say, okay, preprocess, let's create a variable. So preprocessed docs, and in preprocessed docs what I'm going to do is I'm going to basically use the preprocessor dot, again we're going to use process function, and I'm just going to pass my final doc here. Now this will take this preprocessor and process all of my final doc. You can see how intuitive and easy it is to understand. Most of the time what happens, I'm a big fan of LangChain, by the way. I've said that in all of my videos, but their classes are really high level, okay? They're very high abstract classes, which you might not understand properly. That's what's really happening if you don't go to their GitHub repository and read all of the files and classes, by the way. Now at least Haystack provide you the intuitive nature of this implementation, and that's what I'm more interested. You can see how intuitive. What I'm saying here, preprocessor.process, and just use my final doc and process it and give me in preprocessed docs. Now once I have done that, what I'm gonna do is I'm gonna basically write that. So I'm going to first writing it. So document store dot write, and inside the write documents, I'm going to pass this preprocess. Now what it does, let me first show you. We have a document store over here. You can see. Now this will get written there. Okay, this write documents class. It will write that, not class, probably it might be it's a function. Sorry, it's a function. So write document function. I don't know why I said class. So the function will basically write that in this document store. Now once you have done that, let me just show you how you can also update it, by the way, with the retriever. Now here we need a retriever. You can see it's suggesting me. So retriever, and we have initialized embedding retriever. On LangChain you have Hugging Face embeddings, if you remember it. If you are using sentence transformer or any other embedding model from Hugging Face like MPNet, E5, multilingual or something like that. Okay. Now you have something called Hugging Face embedding. That's how you load it in LangChain. Here we have to load it through embedding retriever class. So sad. Not again class, again a function. I don't know why I'm making this mistake. So embedding retriever. Now here what I'm gonna do is, oh, it's a class. See, I was right. I don't know, I will not be wrong every time. I don't know, yeah, it was back in my mind. Now embedding retriever class. Now what arguments it's looking for us from us guys? If you look at it here, it says it's looking for the document store and looking for an embedding model, and look for the some of the other arguments like if you need GPUs and all. So I'm just going to run this. I'll just click on enter, and you can see GitHub Copilot has done the magic. Now in this embedding retriever, we are passing the document store and we are giving an embedding model, but I don't need by which it has suggested me. I need some other embedding model. Maybe if you are using Mistral, I will recommend you can try multilingual E5, which is a multilingual, and you can build a French chat bot, if in French language. If you are interested in that, please go ahead and do that and let me know what you do with that. Now here what I'm going to do is all mini LM L6V2. This is the model that I'm going to use. Okay, and I'm just going to say, okay, use GPU. I don't need it. I'm going to make false here. By default it's false. I'm going to do that on a CPU machine. Now our retriever is ready. Now what I'm going to do, let's also print the retriever here. So you can see retriever is initialized. Now here I'm going to update my document store because we have the retriever, and say, hey, look, use our retriever, because retriever is already using your previous document store in line 46. Now we have to update that after creating the vectors using this sentence transformer model. Once we do that, we will be ready with our ingest.py file, and our vectors will be ready inside that running container on 8080. So let's do that. Now document store.update embeddings and just do retriever. That's it. You are done, guys. Now once we run this, I'm not going to run it because mine is already running, but I'll show you how you can run it. So here what you have to do, you have to just come and say python ingest.py. Once you hit enter, it will take around, for my document it has, for example, it has 500 and more pages, PDFs. It took me around 6 to 7 minutes, depending on that, the number of pages that you have. Once you click enter, it will create the embeddings, and then you can find the metadata information on this running information. So this is our app.py, guys. I hope you understood how you can create vectors. The next thing that we have to do is to create an app.py. So let's create an app.py. I don't know why I'm creating inside data. Okay, by the way, let me just come out here and create an app.py, and I will explain that what I'm going to do here. I'm not going to write the code, otherwise video will be too long for app.py. Most of the code is already available on one of my previous videos that's called YouTube summarization app, where I have used Haystack. Now what I'm going to do, you can see first you can see this is what running your vector database Weaviate on localhost 8080, and you can find the cluster metadata over here. Now what I'm going to do is I'm going to go on my GitHub repository and go inside my gist and copy it, and I will explain each and every line of code. So let me first go on your gist. Once I go on my gist, I'll just click on raw, control A and control C. I'll come back here and I will paste, and I will show you what I'm going to do here. Now let's start from top. Okay, let me do an Alt J here. Now what I'm doing is I'm first loading all of the required libraries. You can see we have to again get Weaviate, we have to get pipeline, we have to basically get PyPDF, might not required. Okay, so it's not required, but anyway, this is there. Now this is very important. What we are doing here, guys, we are saying, okay, from model underscore add, I have a file called model add.py. Now if you come to this model add.py, Haystack has an option through their invocation layer where you can use open source LLMs. Okay, you can bring it all together. They supports right now Llama and Falcon, or if I'm not wrong, MPT's model. Now here I have defined that it's available on the one of their GitHub discussion issues, but I have made a lot of changes in this file right now. Couple of changes. Now for context, I have made the change as 2048, but if you have other model, you have to make those changes. So this is the file. You don't have to make any changes if you are using Mistral 7B. You can use it as it is. Now we have load that. We have few of the fast API libraries dependencies. Then we have ubicon and then load.env. I'm also using open AI model just to show you that how you can use GPT 3.5 or 4 within Haystack if required. Now what we are doing here, we are initializing our app as fast API. You can see in line number 24, and then we are first mounting it our templates and static file. Now what we are saying, hey look, in this templates directory I have all of my index.html files, so this template is set. Now also mounting the static file, which are not going to make any changes, by the way. So in static we are saying okay, directory is static and name is static. If we click on the static, you can find it over here. There's nothing inside it, by the way. Now if you want to use any other images and logos or something, you can put that in static. Now what I'm saying, hey, define get result query. Why was manual of one of the question that I asked, by the way. This is how we are doing it. Okay, embedding dimensions, blah blah blah. We have a prompt template. You can look at prompt template. Given the provided documents, answer the query, make your answer detailed and long or whatever your query, and then you have your joining all the documents, might be different documents, and then joining the documents and answering it. Because in documents, these are basically your context. Okay, look at these other documents and then retrieve the information which are more relevant, okay, from that. And we're also using output parser. So we are using answer parser to parse the answer from those. Okay, now this is your prompt templates, as similar as we have seen in LangChain, where we have prompt template for retrieval QA and conversational retrieval QA chains. Now this is how you have to initialize the model, guys. What you have to do, you have to use the prompt model class of Haystack, where you have to write your model name or path. You can see the full path, and this is where I'm keeping my model, and I'm saying okay, use the llama cpp invocation layer. You can see the invocation layer class, and use gpu as false, and keep my maximum length at 512. You can play around this inference parameter, depending on what you want to do with that. Now here I have a variable called model. Inside this, I'm initializing the model, and then I have a prompt node variable. I'm using a prompt node. Okay, node, if you have studied graph, you will understand what I'm talking. Now prompt node, and here I am passing my model name. Currently you can see it's open source model, which is that we have initialized here. But if you want to use GPT 3.5, you have to just unhash this line. You can see, and you have to unhash this line to use GPT-X model or Palm model or any other model that Haystack supports, just to show you that how you can also use it if you are not happy with the speed, latency, whatever reason, right? You can do that. Now maximum length of 1000, you can have a look at that. Okay, now this is fine. Now you have a default prompt template as prompt template. Okay, now let's make this as 512 as well, guys. Too much, I just want to make it a little small. Okay, 512 and prompt node. You can see the retriever. Now this is your retriever embedding, same thing that we have done because here we have to pass the query through the document store. And now what we are doing, we are creating pipeline, and in that pipeline we'll start adding one by one all of the required pipeline. If you have worked with scikit-learn, you will have seen scikit-learn pipeline, where you add all of the pre-processing modules, the model modules, if you have to do some label encoder, then you also do it in between. So here what we are doing, we are in line number 67. We are saying okay, have a variable called query pipeline, which initiate a pipeline from Haystack. And from there we are adding nodes in that pipeline, one node after the other. Now in first node we are adding our retriever, and retriever is taking input as query. This query will be passed by the end user in the input box. And then we have second node, that is your prompt node, and use the previous retriever. You can see it over here. That's how intuitive it is. And then we print the query pipeline, and then we add doing some retrieval like JSON response, use the top 5 documents, use the query as query, and then just running it together. You can see basic Python thingy over here. Then we have all our relevant documents and their content, because we have to show in the UI. Here document doesn't mean that it's a PDF, it's the document, the context, the knowledge base. And then we're using regular expression to look at how to make the answer little beautify or something. Don't get garbage responses or something like that. Okay. Now here is the fast API thing, a very small thing. Okay, we have first, which is called get index.html. Okay, maybe you can also have redirect response, which is not here for 8000. And then this is your main endpoint, which is get answer. We are making a post request. Okay, and here is saying, okay, define get answer, takes your question as a string, and then use the function that we have on top, get result, and just enable encoder from, just to make your answer a little beautified. That's it. Now let's run this, guys. We are done with app.py, and we already have ingest.py that you see. These are two things that you need with your model add.py. So we started from setting up Weaviate inside a Docker container. We then created an ingest.py file that takes your PDF using Haystack preview component, create the embeddings, store that in a vector database running inside container, and then we use Llama CPP invocation layer to basically use an open source model within Haystack to make all this inference and build a RAG implementation. That's what we are doing. Now, once we are done with this, we're just gonna run the application, guys. Now let's do that. Okay, sorry. Ooh. Because that was commented, guys, right? That's why we were not able to do Python app.py, but you can also do Python app.py. You just have to make the couple of lines, in that app.py. Okay, now what I'm gonna do is I'm going to go inside this here. Where is that app running? Let me just copy this question and see if we are getting the same response or not. Now I'm just going to refresh this here, and I'm just going to copy the same question and try to. Now you can see this is how the UI looks like. This is basically the template that we have, index.html file. Here you have enter your query. Once you click on submit, it will basically retrieve the information for you in the right hand side, and also gives you your knowledge base, the context to decide. Okay, you make sure that, okay, we are retrieving it from that. Let's run it. Now once you run it, it will take little time, so I'll just stop the video and come back in the next 30 seconds. You can see we got our answer, guys. Let's say the manual of air traffic service, the same answer that we got earlier. Now let me also show you that how you can also use fast API backend if you want. And if you click on docs, it takes you to this Swagger UI, where you have some specification about your API. And you can also use this as in your Postman. You can try it out in Insomnia, Postman, or any other API clients. And you can also test it over here, like in get answer. When you click on try it out, you can just put your questions over here. So that's why we're using fast API. It helps you build the APIs, and also you can use that through Jinja 2 templates or something on the front end. That's the beauty of it. Now let me just go back to localhost 8000. Once I come here, let's ask one more question. So this is the document that I am using. So what I'm going to ask is uh, Airport Authority of India to provide air traffic services. Let's ask this question. What are the services air airport excuse me Airport Authority of India provides? Now this is what I'm going to submit, and this is going to be our last QA stint. It will take little time, but once it generates the answer, probably we'll know, right? So what I'm going to show, what we have done in this video, guys. Now let's talk about it quickly. So we have started from setting up Weaviate through Docker Compose file, running on a inside a Docker container on 8080. Now we have used Haystack preview component to use PyPDF to basically get the text out of it, and then we have used sentence transformer model to create embeddings, and then we have updated that in the vector database, sorry, on running on 8080. Then we have an app.py file, which is basically which has been created using FastAPI that uses the Llama CPP invocation layer within Haystack to use open source LLMs. And I also shown that how you can use GPT 3.5 or 4 if you have access of GPT-4 to do that. Now, all of this code will be available on my GitHub repository, and you can download Mistral 7B from the blog. I will give you the link in the description. And yeah, pretty much this is what I wanted to do in this video. So all these static templates, you can see the model inside this. All this will be available on my GitHub repository. And let me know what cool thing you are building with this approach end to end. You have your documents, that is your knowledge base. Then you need embedding model, open source vector database running inside a Docker container, an LLM, and then an application, a simple app using running on a microservice. End to end, let me know what you are building. I'll be more than happy to see how you extend this further on your use case, on your ideas. If you have any thoughts and feedbacks, you can also let me know. Let me show you that where you can find this on my GitHub repository. Come to this AI anytime, back to GitHub. Here I'll just go on your repositories, and here you can find the file Haystack and Mistral 7B RAG implementation. Once you click on that, you will find right now all the files. I will upload static and template file, a folder very soon inside this, the index.html, and you can use it on yourself. Okay, and you can see the batches has been uploaded. Okay, here it takes around, sometime depends, how many queries you are running. This is my second query, so it might take a little longer. Yeah, but this is what it is, guys. So if you have any thoughts, feedbacks, and questions for me, please reach out to me. You can reach out to me through my social media channels. I'll be more than happy to answer it and help you wherever required and learn from you as well. Okay, that's all, guys, for this video. If you haven't subscribed the channel yet, do subscribe, like the video and the channel, and share this with your friends and peer as well. Thank you so much for watching. See you in the next one.